Hello everybody, you have exam 1 coming up tomorrow at 2 p.m. Okay, so to prepare for the exam, of course you have to watch all pre-recorded lectures, through chapter 14. Okay, and please watch the review video quiz 1 and quiz 2. That is really helpful for you. Okay, so review for quiz 1 and review for quiz 2, please watch that video also. That those two videos help you. And today I want to talk a little bit about the exam. This is not enough, so you can say this is review for the exam, but this is not enough. Okay, I want to give you some important information only. Okay, so we learn about the kinematics in chapter 3. Okay, the motion we call the linear motion. If the object, let us suppose this is the horizontal line, and if the object is moving from here, let us suppose your initial velocity is v0. v0, this is your initial velocity, and this object, if it is moving at constant velocity means no acceleration. In that case, simply velocity you can write down delta x divided by t. Delta x is the displacement. Okay, if the velocity is constant, you can simply write down delta x divided by t. Or if you consider average velocity is constant, you use the same formula, delta x divided by t. Okay, but here I would like to do that. The object is accelerating, and let us suppose A is acceleration. A, this is constant acceleration, not constant motion. I say constant acceleration. Constant acceleration, and it starts from velocity, this velocity v0, and after certain time, let's say time is t, this is time. After certain time, it travels a certain distance delta x, this is a displacement. After certain time t, it travels delta x, where you have let us suppose this velocity, this is your final velocity, v is the final velocity, v, this is your final velocity. This is not constant motion, this is accelerating motion, changing motion. You have acceleration. So if you want to calculate the acceleration, please use this equation. You need this equation, okay, in your exam. A, acceleration A, this is equal to final velocity v minus initial velocity v0 divided by time. This. You need this formula. Acceleration is v minus v0 divided by t. This formula is same as v equal to v0 plus at. These two formulas, that's the same. This formula is same, okay? They are not two different formula, they are the same formula. So to calculate the acceleration, acceleration is equal to final velocity minus initial velocity divided by time. So if the object start from rest, the question sometimes this question says like this: if the object start from rest, what is your initial velocity? In that case, your initial velocity is 0. If the object start from rest, your initial velocity is 0. And if the object come to the rest, what does that mean? Your final velocity is 0. If the object comes to rest, that means your final velocity is 0. Object come to stop, that means final velocity is 0. So you need this formula, okay everyone, don't forget. And it is also better to know, there are other formulas also. We call displacement formula, delta x equal to v0 t plus 1/2 a t square. This is the second equation, we call kinematics equation. And you have a third equation, is final velocity square equal to v0 square plus 2a delta x, and your average velocity is, this is a v bar, this is initial velocity v0 plus final velocity v, divide this by 2. This formula, these including this one, we call kinematics formula, but I think you need this one in your exam. But please recall these also, okay? Don't spend too much time on these things, but you need this. So this is about the kinematics equations. So if the object is moving at constant motion means same velocity, equal velocity everywhere, no acceleration there. But here object is accelerating. So if the object is accelerating, you have a changing motion, changing velocity. So your acceleration, you have a certain number there. Don't confuse. But we did the circular motion also. We did the circular motion like a centripetal force, centripetal acceleration. Let me recall that here. So let us suppose object is moving in a circular path. This is a circular path having radius r. Object here, it is moving at, let's say, let us suppose 10 meter per second. V is 10 meter per second. Okay, and radius is suppose 5 meter, whatever given. Object is moving in a circular path like this, circular path. If the object is moving in a circular path, it needs a force to keep the object in a circular path because the direction is continuously changing here. Let us suppose the object is moving in a circular path at constant speed, 5 meter per second, everywhere 5 meter per second, here also 5 meter per second, 5 meter per second, here also 5 meter per second, here also 5 meter per second. So is your velocity constant here? What do you think? No, sorry, not 5 meter, I'm sorry. Let me make this 5 meter, okay? So 5 meter per second everywhere. Everywhere 5 meter per second, 5 meter per second, 5 meter per second, 5 meter per second. This means your speed is constant, velocity is not constant here. Why? Because look, this velocity is to the right, 5 meter per second. This velocity is down, 5 meter per second. This velocity is to the left, this velocity is up. Different direction, either magnitude change or direction change or both change. That velocity is changing velocity. That means object is accelerating. This motion we call uniform circular motion. This motion is called as uniform circular motion. But still object is accelerating. If the object is moving in uniform circular motion, object is accelerating, there is an acceleration, and that acceleration is pointing toward the center of the circular path, and the centripetal acceleration AC, you need AC is equal to V square divided by R. So in this case, object is moving in a circular path, although here your speed is constant, but you have acceleration, that acceleration pointing toward the center, that is called as the centripetal acceleration. And centripetal acceleration is V square divided by R. V is given 5 meter per second, and you have to square this, and R is 5 meter. So how much you get? It is simply 5, I think 25 divided by 5, so that is 5 meter per second square. This is the centripetal acceleration. Okay, don't confuse uniform circular motion and uniform motion. They are different. Uniform motion means in a straight line, linear motion, straight line. In that case, you're actually this one. Look here. Let us suppose this is a horizontal line. Here, this person has a speed 5 meter per second. 5 meter per second. Here also 5 meter per second. 5 meter per second. So what is acceleration here? Look. Same magnitude 5 meter per second, same direction 5 meter per second everywhere, same direction, same magnitude. In this case, acceleration is 0. But here 5 meter per second, 5 meter per second, 5 meter per second, 5 meter per second, but the direction is changing. This is a circular path. So in this case, your acceleration is not 0. This is called as uniform circular motion. This is simply people call constant motion or uniform motion. Okay, but in this case, acceleration is 0. So don't confuse, okay? So you need to know this, and if you know the centripetal acceleration, and if you want to calculate the centripetal force, F of C, this is mass times centripetal acceleration, or centripetal force is mass, acceleration is V square divided by R. This is the formula to calculate the centripetal force. So please recall this also, okay? So this is about the centripetal force, centripetal acceleration. Centripetal force is pointing toward the center. Centripetal acceleration is also pointing toward the center. So you need to know this. Okay. And let me go back to the kinematics again. I talked about the kinematics equation, and let us think about the free fall. You know, please recall the review for quiz 1. You know the free fall, object freely falling. We simply ignore the air resistance. For example, let us suppose this is the tower, here is the ground, and if you drop the object from here, so your initial velocity in y direction, it is simply 0. If you drop the object like this, and if you ignore the object moving vertically downward, you know that is called as the free fall. Object moving under the effect of gravity only, no air resistance, that is free fall. And here you have a two formula. If you want to calculate the velocity after a certain time, use this z times t, and this height from here to there, okay, this height is vertically downward, so h equal to 1/2 zt square. Sometimes you have to calculate the time by using the height, so in that case your time is simply, you can use this 2h divided by gravity and take a square root. So this is the formula. Actually these two are the formula, free fall formula, but this time is you can get from the second equation, free fall. Okay, now my concern here is, let us suppose you have a two object. This is a ground and there is a tower. You have a two object right here, two object, okay, two object, same point. Like you can look at this, I have a two object, one is blue, another one is yellow. These two objects, same point from the ground, like same height from the ground. What I would like to do is, I want to throw horizontally, both objects I want to throw horizontally. From the same point, I want to throw horizontally, both objects, okay? So the first, let me draw this way. The height is same, okay? I cannot draw that. The height is same. One object here, let's say this is the blue one. The height is same, please don't confuse, okay? Height is same, like this. The height is same, side by side, okay? Because I cannot draw that, that's why don't think the blue object's height is bigger. No, the height is same. And you have other one, this is the yellow one. The blue one, your initial velocity is, let's say, 10 meters per second. The yellow one, your initial velocity is, let us suppose v0 is 5 meters per second. But both 10 meters per second and 5 meters per second, both are the horizontal velocity from this point, same height, don't confuse, same height. But initial horizontal velocity is different. The blue one has initial velocity 10 meters per second, the yellow one has a 5 meters per second, and this is the height for both. Height for both is same, h is same for both. What happened? The yellow one, it goes like this. The blue one, it goes like this. Okay, this is the blue one and this is the yellow one. Now my question is, which one hit the ground first, blue or yellow, or do they hit the ground exactly at the same time? If we ignore the air resistance, okay? So which object hit the ground first, or do they hit the ground exactly at the same time? What do you think? Because the horizontal distance traveled by both objects, the vertical distance, this vertical height traveled by both objects is same. And the initial vertical, this is horizontal velocity, initial vertical velocity v0y is 0 for both. Initial vertical velocity is 0 for both objects, blue and yellow. And they travel the same vertical height. That means they hit the ground exactly at the same time. If the first ball takes like whatever, let's say if the first ball takes 5 seconds to reach the ground, second ball also take exactly same 5 seconds. Both balls hit the ground exactly at the same time. Please keep this in mind. So if the first ball takes like a 0.2 seconds, second ball also take the same time, 0.2 seconds. But of course this distance we call the horizontal displacement, and this displacement, they are different. Okay, so please note this. You need, probably this is helpful for you. So this is about the free fall, and you know you have to talk about the projectile motion. You have to learn about the projectile motion, object moving under the effect of gravity. So please recall that. And in kinematics, like you can think about it like this. If you throw, you have object. Let's say this is the object. You throw the object vertically up like this, vertically up. From your hand to this point. This is a point at the maximum height. How long this object take to reach the point at maximum height? It is like this. You have object. Let us suppose you throw from here v0 in y direction. You can write down it is 10 meter per second. Initial velocity is 10 meter per second. The object goes up, vertically up, like this. I don't know this length. I don't know this height. But what do I know is what is your final velocity here. Look, I throw the object from here, 10 meter per second, vertically up. From here to there, right here, what is your final velocity? Object goes up, 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 up. Now it has to stop there so that it can come back. You understand me? So here your final velocity is 0. Okay, so final velocity is 0. So what is this time? What is the time? To go from here to there only, not to come back to your hand, just to reach the maximum height. How many seconds? How do you calculate this? Here your gravity is, let us use 9.8 meter per second square. Because if you throw the object like this, your acceleration is 9.8 meter per second square. That is due to gravity. So how do you calculate the time here? You can do this equation. Vy equal to v0y minus g times t. Why minus? Because gravity is negative. You can write down the plus here also. If you write down plus, then plug negative 9.8 in that case. Okay. So this equation is just like this. A equal to v minus v0 divided by t. This is the same equation. So final velocity you have 0. Initial velocity 10 meter per second. Right? Gravity 9.8 meter per second square. What is your time? Now you can calculate the time from here. So this is negative 9.8 meter per second square times t. So bring this negative on this side. So you can write down 9.8 meter per second square times t equal to 10 meter per second. So how do you get the time? Just divide by 9.8 meter per second square here, 9.8 meter per second square there. So these cancel out, then you get t only. So whatever you get, 10 divided by 9.8. So it is 10, I don't have a calculator, so 10 divided by 9.8. Please use your calculator, whatever you get, this is in second. That's the answer. Okay, that's the answer. So this is not too hard. And you please recall the projectile. I already talked about the projectile in the review video for quiz 2. Please look at that. Like projectile motion, what is projectile motion? What are the two components, horizontal component and the vertical component of the projectile motion? Horizontal component is always constant because we ignore the air resistance. And what is time of flight? What is the maximum height? What is horizontal displacement? That kind of things. Okay. So for example, here you have a ground and this is your tower. If you throw the object from here with the, let's say, initial velocity is v0x, and object goes like this. Object reaches this point. Okay. So this we call the horizontal displacement delta x, or people they also call horizontal range. And the horizontal range is delta x. This is equal to v0x times t. T is the, you can use uppercase t or lowercase t, that is not a big deal. This time is the time to reach the ground. From here to there, how long it takes. Sometimes you have to calculate the time by using the height. If the height is given, your time t equal, 1/2 gt square is equal to h. This is the formula. So your time is equal to 2h divided by g and take a square root. And you can calculate the delta x. Please recall this. Okay. So this is about the projectile, and you need to know the Newton's laws of motion. There are 3 laws. Law of inertia. Everybody continues in the state of rest or state of uniform motion in the absence of an external force. That is the first law. The first law is called as the law of inertia. Okay. The second law is this: F equal to mass times acceleration. This. Okay. If the force is given, this is a net force. Okay. You can write down F net, or simply people they write down F only. So F equal to mass times acceleration. So if the net force is given, mass is given, you can easily calculate the acceleration. And look, from here your acceleration is F net force divided by m. So please recall this. And this is the second law, F equal to ma, mass times acceleration. And third law is, to every action there is equal and opposite reaction. Like if I hit here like this, if I apply 100 Newton force on the board also apply exactly the same force on my hand. If you kick the ball, you apply the force on the ball. Let us suppose you apply 200 Newton force on the ball. How much force you experience from the ball? Same force, but opposite direction. Opposite direction. Okay. To every action there is equal and opposite reaction. I told you that. Like the Earth pulls the moon. The moon also pulls the Earth. Action reaction, equal and opposite direction. Okay. And you also learn about the gravitational force. You have two objects, m1, you have another object m2. If they are at a distance d, the force, attractive force, gravitational force is always attractive. This is equal to g m1 m2 divided by d square. Okay, and here gravity, this is universal gravitational constant, which is 6.67 times 10 to the power negative, how much? I think 11 Newton meter square per kg square. Please recall this. So if the object is coming closer, the force is increased. If the object is coming closer, the force is increased. Now for example, let us suppose you double this mass, you double this mass. You double both mass and you double the distance. What happened to the force? You double both mass, you double the distance. What happened? What does that mean? That means this. F equal to g m1 m2 divided by d square. This is initial, let me call F1 initial. You can write down initial, not a problem. Initial. Now what you will do? You double this mass, you double this mass, and you double the d also. That means your F final. F final is, g is constant. You double first mass 2m1. You double second mass 2m2. You double the distance 2d, but you have to square. Many students, they make a mistake here, 2d square. Okay, so what happened here? Any change? Look, this 2 square is 4. This is, isn't it, 4 g m1 m2 divided by 2d square is 4d square. Now look, 4 cancel out. You get the same thing, g m1 m2 divided by d square. So if you double the mass, both mass, and double the distance, there is no change. But what happens if you cut the distance into half? You want to cut the, let us suppose right now this is, the distance is d. Next time you want to make this close. You want to make this distance is, you want to cut into half, d divided by 2. What happened in this case? Your new force, you can call final force, is g m1 m2. You want to keep the mass same mass, but you want to cut the distance into half only. That means d divided by 2, but you have to square this. Distance cut into half, d divided by 2, half, but you have to square this. So if you do this, what happens? G m1 m2 divide this by d square divided by 4. This means 4 times g m1 m2 divided by d square. So this is initial, 4 times the initial. That means quadruples. If you cut the distance into half, then the force is quadruple. If the distance, if you increase 2 times, 2d, if you make 2d, then the force becomes 1/4. So please play with this equation. Okay. So this is about the gravitational force. And we talk about the linear momentum, work energy, power formula, conservation of energy, conservation of mechanical energy. Again, I have to tell you, please recall watch the review video for quiz 1 and quiz 2. But here I want to talk one thing about the conservation of mechanical energy. What is conservation of mechanical energy? Is if there is no friction, the sum of the kinetic energy, this kinetic energy plus potential energy, initial, this is equal to kinetic energy plus potential energy, final. So if there is no friction, we call that non-conservative force also. So if there is no friction, the sum of the kinetic energy and potential energy remains constant. That is conservation of mechanical energy. Okay, that is conservation of mechanical energy. So please know this, conservation of mechanical energy, and let me give you the example. How do you apply this conservation of mechanical energy? Don't confuse. There is conservation of mechanical energy. There is conservation of energy also. Conservation of energy is neither created nor destroyed, but you can transform from one form to another form. That is conservation of energy. But right here I am talking about conservation of mechanical energy. The sum of the kinetic energy and potential energy remains constant if there is no friction, if there is no non-conservative force. Okay, so let us apply them. You know the roller coaster. Let us suppose this is a roller coaster. Okay, and here is the ground. You measure the height from here. You measure the height from here, from this point. Okay, and let me call this point is point A. This is at a height, whatever height is given. For example, 200 meters. 200 meters. This is what is the height here? Height is 0 here. This is point B. Height is 0. Okay, you measure from here. Your height is 0. And another point here. You can choose any point. Let's say choose this point. This point C. Let us suppose this height is 160 meters. Whatever given, just don't copy this number. Okay, I randomly chose the number. And roller coaster car is here. This is a roller coaster, this car, and the rider, passenger, whatever you call there. The mass of this whole thing, I mean the rider and the car, whatever. Okay, the mass is, let us suppose mass is 100 kg. It is not at rest at point A. At point A, this is moving at 25 meter per second. Moving at 25 meter per second. But look, this at point A, the speed of this whole thing, car, is 25 meter per second, and the mass is 100 kg. And this is above the ground. This here, 200 meter above the ground. So my question is, I gave you the information here at point A, but I want to ask you, what is the total energy at point B? What is the total energy at point B? Or what is the total energy at point C? That is the same thing. Because mechanical energy is constant. How do you calculate that? Kinetic energy plus potential energy at point A equal to kinetic energy plus potential energy at point B. This is equal to kinetic energy plus potential energy at point C. Same thing, because there is no friction. Okay, no friction at all. So if you calculate the kinetic energy and potential energy at point A, you have the same energy at point B. So what you have to do is, what is total energy at point B? That is my question. What is total energy at point B? So total energy at point B is equal to total energy at point A. Okay, so what you have to do? Total energy at point A is this. Total energy at point A, you can calculate this. This only this. So total energy at point A is kinetic energy plus potential energy at point A. What is kinetic energy formula? Kinetic energy formula is 1/2 mv square. Everyone, you need this formula. Okay, kinetic energy formula is 1/2 mv square. Potential energy formula is mgh. You need this. Okay, so the kinetic energy is 1/2 mv square plus potential energy is mgh. So this gives you the total energy. So plug here 1/2. Mass is 100 kg. Speed is 25 meter per second. 25 meter per second, but you have to square this. Plus, this is kinetic energy. Now the potential energy M is 100 kg. Gravity, let me use 10. Whatever number given, use that 10 meter per second. So this is a G, gravity. And height is, you have to use from here to there, which is 200 meter, or whatever given. Here it is 200 meters. So use your calculator, get this number. What is this? This is total energy at point A. Now what is your total energy at point B? Same number. Same, because energy is constant. Mechanical energy remains constant, no friction. So this, whatever you get this number, please do it. I don't have a calculator, you get a big number definitely. Okay. So this energy is also equal to the total energy at point B. Total energy at B. Same thing. Or at C also. Because energy here, energy there, or energy here, they are equal. Okay, they are equal. So keep in mind the object is in motion here. If it is in motion, you have to count both kinetic energy and potential energy both. But if the object starts from rest, your kinetic energy is zero there. Okay. But normally in this case here you have a motion here. So this is how you have to do it. So this is the roller coaster problem. And you have a kinetic energy, potential energy formula, conservation of energy. You have a work done. Like for example, in the same chapter we talk about the work done. Okay, work done formula is, work done is W is basic formula is F times D. This is the work done formula. Okay. Now let me give you one example. Let us suppose this object. Consider this is like a heavy object, 10 kg object. I lift up this object and bring back to the same position. From the ground, let us suppose the object is sitting on the ground. Heavy object, heavy object. Okay. I lift up the object from ground to this point and bring back to the same position here. How much work is done here? You lift up the object and bring the object back to the same point on the ground. What is your total work done? I mean, work done. Zero, no displacement. You start from the ground and you bring the object back to the same point. So no work is done there. Okay. So please think about that. And another thing is, please recall linear momentum. Linear momentum is mass times velocity. This is the basic definition of linear momentum. And you have a conservation of linear momentum also. For example, you know the conservation of linear momentum formula. Please recall that this is the linear momentum formula is conservation of linear momentum is m1 v1 I plus m2 v2 I. This is equal to m1 v1 f plus m2 v2 f. This is a conservation of linear momentum formula. But here I want to ask you the example. Let us suppose this is the object having certain mass like m equal to 2 kg. This is moving at, let's say, momentum is given, not the velocity. Let us suppose this object's momentum is, let's say, 10 kg meter per second. This is the momentum of the object. This object is moving to the right, and this object has a momentum 10 kg meter per second. And that is another big object. Another big object. Let us suppose m equal to whatever, let's say 4 kg, something like this. I chose the number randomly, okay? These are not my practical number. And what happened, you know, the first object, this is M1, this is M2. M1 hit the M2 and stick together, stick, embedded, okay? And after collision, what happened is, they move together. They move together. That means they have a common velocity, same velocity, they move together. Like V here, same velocity. Of course, the velocity is, I think, decreased, but they have a common velocity. What is the momentum of these objects together, both objects together? No friction. First object hit the second object is at rest. Now the first object hit the second object and they move together. They stick together, they move together. What is the momentum of the both objects together? Because if there is no friction, the momentum remains constant. That is conservation of linear momentum. If it is 10 kg meter per second, you must have the 10 kg meter per second here. Velocity is different, but the momentum is same because momentum remains constant. The momentum here is also 10 kg meter per second because the total linear momentum before collision and after collision, they are equal. Okay, so please think about this also. This is the linear momentum. And we also talk about the rotational motion. Please keep in mind there is torque, recall the torque. recall the rotational inertia, recall the conservation of angular momentum. If there is no external torque, your angular momentum remains constant. For example, let us suppose this is a big disc. If you go to the amusement park, fun park somewhere, you have a big metal disc rotating like this. So right here you have an axis. This is your axis of rotation, and you are let's say you are walking radially outward like this. You walk like there is an axis. You walk radially outward. What happens to the angular momentum if there is no torque? Angular momentum always remains same, because if there is no external torque, angular momentum remains constant. Please check that, the angular momentum things. Okay, so that is about the rotational motion thing. There is lot of things, I cannot do everything else here. Okay, and we talk about the fluid, like what is pressure, what is density, what is buoyant force, what is Archimedes principle, what is Pascal's principle, what is Bernoulli's principle, continuity equations like that. So the fluid, start from here. Density is mass per unit volume. Density, we simply write down rho. And there is another term, pressure. Pressure is, what is this? Force per unit area. For example, let us suppose you have a table and there is one object, this object. Okay, this object mass is, let's say, 5 kg. Object sitting on the table like this. Consider this object, 5 kg object sitting on the table. What is the pressure exerted by this object on the table? Force per unit area. So if you have to calculate pressure, you have to calculate force and area. If the object is 5 kg, what is the force then exerted by the object? Force is, you can do this, force is equal to weight, but weight is mass times gravity. So 5 kg times 9.8 meter per second square, that is the force. But how to get the area? Area is, you have to calculate this area. So how do you calculate this area is, you multiply this length and you multiply this width. If it is square, same thing, you know how to get the area of the square. Length times length. So get the area, not the whole area, just this area, because the object is sitting like this. So you have to count only this area. How to get this area? In this case, because this is like a rectangle, so multiply this and multiply this. That gives you the area. So this area, and you need a weight of this object. Weight is mass times gravity. Then you can calculate the pressure. Okay, so please note this. Okay, so you need to know the pressure. This is very basic definition, but if you want to know the pressure exerted by the liquid, like this, you have a liquid column, and liquid you fill with the liquid like this, any type of liquid. And okay, so here if you want to calculate the pressure here, pressure due to the liquid only, your pressure is rho. Rho is the density of the liquid, z, this is gravity, and height is this height h. So the pressure exerted by the liquid column, it depends only on the height, and the liquid density is constant. We don't do the changing density. So rho z h, please keep this in mind, you need this. And this is pressure exerted by the liquid column. And please recall the Pascal's principle also, you need that. And we talk about the buoyant force. Okay, if you weigh the object in the air and if you weigh the object in the water or any liquid, you get a weight difference. In the air, for example, 4 Newton, in the water you get something like 1 Newton. What is the loss? 3 Newton. Weight lost in the water, that is the buoyant force. Weight lost in the water, that is the buoyant force. If you want to calculate the buoyant force, you can write down also the formula is F of B, that is buoyant force. Buoyant force formula is, there are different ways, so I can write down just 1 mF times gravity. What is this? This is mass of the displaced liquid. If you immersed something in the liquid, that object displaced the liquid, certain amount of liquid. So mF is the mass of the displaced liquid. If you go into the swimming pool, what happens? you displace the water. How much? Your volume, equal to your volume, not your weight. If you get inside the swimming pool, you displace the water equal to your volume, not your weight. Okay, so mass of the this is mass of the displaced fluid, mass of displaced fluid. You can write down liquid also, displaced fluid. So mf times d. I don't think you need this, but better to know, okay, to answer the conceptual questions also. So the buoyant force, it is upward direction. Why? Why the buoyant force is upward direction? The reason is, for example, let us suppose this is the pond, lake, whatever. You have a liquid here. You have a liquid here, and if you keep the object right here, if you keep the object right here, there is a pressure here. This pressure is, look, the pressure against the bottom here, upward direction, and the pressure here is downward direction. This is P2, this is P1. There is a pressure difference. Due to this pressure difference here at the bottom, at the top, so here P2 is greater than P1, so P2 minus P1. There is a pressure difference. Due to this pressure difference, we experience the buoyant force. You need to know this, okay? So the pressure against the bottom here in upward direction, and pressure against the top here, downward direction. There is this one, P2 is bigger than P1. So there is a pressure difference. That is why there is a buoyant force in upward direction. You need to know this. You need to know this, okay? So the buoyant force, it depends on the, like, you know, the how much liquid you can displace. The buoyant force is, again, look here, I gave you the formula. Buoyant force is mass of displaced liquid divided by gravity. Let us suppose, and this is a pond, lake. Here is water. This is water, or any liquid water. Okay? And there is, let's say, 1 kg aluminum, 1 kg aluminum, and let us suppose 1 kg lead. I don't draw the diagram, but what happens is 1 kg aluminum sphere, solid sphere, and 1 kg aluminum solid sphere. They are sitting next to each other at the bottom of the pond, bottom of the lake. One is aluminum sphere, solid, another one is lead sphere. I can give you the hint. The lead is heavier than aluminum. That means the density of lead is bigger than density of the aluminum. Now can you tell me which object experienced the bigger force, bigger buoyant force? Lead or aluminum? The idea, the hint given here is the lead density is bigger than aluminum density. Now what do you think? Which object is bigger in volume? Aluminum or lead? Because both are 1 kg. That means your aluminum is bigger. Lead is smaller because lead density is big. So if you draw, this is small, lead is smaller. This is a lead. Aluminum is big. But both are 1 kg. Both are 1 kg. This is also 1 kg. Both are, the mass is same, but the density is different. So the aluminum is kind of big. You can think about 1 kg iron and 1 kg cotton. Like let's say 1 kg foam. Foam, you know the foam, like a mattress thing. 1 kg iron is really small. 1 kg foam is very big. That means the volume of the foam is very big. So if you have 1 kg aluminum, 1 kg lead, look, 1 kg aluminum is bigger in size. Lead is smaller. So which object displaces more water? Of course aluminum. But we know that mass of the displaced water or liquid times gravity. That is the buoyant force. And aluminum displaces more water. That means this aluminum experiences the bigger buoyant force. Bigger buoyant force. Because aluminum displaces more water. Okay, but both are synced, okay, because the density of the aluminum and density of lead both are more than water, so both objects they sync. Now another one, let us suppose, you know, styrofoam. Let us suppose there is a styrofoam sphere. The density of the styrofoam is smaller than water, that's why it sinks. and you have the same size of same size of iron, same size. The sphere, one is styrofoam, another one is iron. Size is same. I'm not saying weight is same. Size is same. So here you have a, if you take the, like, let us consider this is iron. This is iron. Then what happened? If you drop the iron from here, what happened? Iron sink, because its density is more. Iron sink goes to the bottom of the lake. Styrofoam cup is on the top. That means styrofoam is floating. Iron is sinking there. Which object experienced the bigger force? Styrofoam or iron? Iron is inside the water. Styrofoam is partially inside the water. It is floating. So which object experienced the bigger buoyant force? Don't think styrofoam sphere is floating. That is why it has a bigger buoyant force. Don't think that way. Think the amount of liquid displaced. Iron is completely inside the water. It displaces more water because the size is same. I told you that. Size is same and iron is inside the water. That means it displaces more water. The styrofoam sphere is only partially inside the water. It displaces less amount of water. Okay, so the iron experiences bigger buoyant force, not the styrofoam, because styrofoam is floating only partially inside the water. So please think these things. I hope this is helpful. Not enough. Okay, so you have to read a textbook. You have to watch the pre-recorded YouTube video. It is better if you can watch the review video. I hope you did that already. So this is just some helpful tips only. Okay, so I want to stop here. Thank you.